You have a case of cyclist coming down. The cyclist is not exerting any effort to come down, not cycling. Okay, just let go. So you have mg sine theta going down because of the gravity. Okay, because mg is here. And then F is the friction on the floor. So if the cyclist coming down, we have a few cases. The cyclist moving down. If mg sine theta equals to the friction, it's either not moving, or if it moves, it will move with constant velocity. Okay, so the track is said to be friction compensated because mg sine theta equals to F. You have two possibilities. Either it's not moving, object not moving, or if it move with constant velocity. So this is a case of friction compensated track. But if mg sine theta is more than F, mg sine theta more than F, there's a net force moving along the track downward. The object actually accelerates. So you can say it's something like this: F net equals to ma. So you have mg sine theta minus F equals to ma. Okay, so let's say this value is 10, this is 7. So let's say the object is 1 kg, 1 times a. So your acceleration is actually 3 meter per second. 3 meter per second. Okay. So there's a net force moving along the track downward. How about we look back at this? If the cyclist is trying to go up with some kind of effort, okay, effort, he has to overcome two things: mg sine theta and friction. Because mg sine theta and friction now is along the same direction. In the situation just now, it was opposite direction. Look at this one. These two are in opposite direction. But now they are in the same direction, so your effort must overcome the two things. So your effort must fight. Put it here, versus. Your effort must versus mg sine theta along with friction. Okay, so it's always harder to go up the hill. Okay, this is what we know from ourselves climbing up the hill. We felt that it's more difficult than coming down. Okay, of course coming down is quite difficult as also if you are tired. But if you look at things ideally, the effort to go up is actually more because you have to overcome two things: gravity and also friction. Going down, the gravity actually helps you. So if the cyclist is moving up, the effort, if it is equals to mg sine theta plus F, if you are lucky, you can actually move up with constant velocity. If your effort equals the forces that try to pull you down. Okay? But if you're really strong and your effort is really more than the gravity and the friction, let's say here 7, let's say here 4, but here you have 15. 15 minus 11, you still have net force of 4 Newton. If you have net force going up 4 Newton, meaning you are accelerating upward along the track, and you are actually a very strong person because you are able to do this kind of achievement. Okay, so the conclusion is going up is always harder than coming down. Okay, coming down, if you don't have personal effort, then mg sine theta more than friction, then you can go down quite fast. But if you also cycle down, the effect is really fast. You will go down really fast.